Birds tend to flock together in trees, in ponds and lakes, and even on ice-covered land. Although there are many different types of birds, birds often group with other birds like themselves, sometimes in pairs, which are groups of two. Birds come and birds go. Most don't stay in one spot for long. Why? Because they can fly. Except some, like this unusual bird. It lives where there's ice. It swims in cold water, and it waddles around. It's the penguin. Birds flying, wading in water, and waddling around often add and subtract themselves from groups. This changes the sizes of the groups. Let's see some examples of adding and subtracting. Flamingos are pink birds with long necks and long legs that live in warm areas like Florida. They spend a lot of time getting food under the water. Here's one flamingo, and then another. One flamingo added to one flamingo equals two flamingos. You can write it as a number sentence. 1 plus 1 equals 2. This is the symbol for adding or addition. It's called a plus sign. This is the symbol for equals or equal to. Now let's add some more. 4 flamingos are looking for food. In walk 2 more flamingos. How many flamingos are there altogether? Start with the 4 flamingos, then add the 2 that join them. 4 plus 2 equals 6. Adding things to a group always makes the amount in the group greater. Penguins are unusual birds that live in very cold areas. Here's a group of 5 penguins. Let's count them. There's one nearly hidden behind number 2, 3, 4, 5. Then one penguin walks away from the group. This leaves 4 penguins. We can write this as a number sentence using subtraction. 5 minus 1 equals 4. The minus sign shows subtraction. Subtraction is the opposite of addition. We take away something instead of adding. Here we see 5 penguins standing on the ice. 4 of them go away, so 1 is left all by itself. 1 penguin. Here's the number sentence. 5 minus 4 equals 1. Subtracting things from a group always makes the amount in the group less. Adding or subtracting things changes the amount of things. Adding gives you more, and subtracting gives you less. These flamingos are busy looking for food. How many are there? 1, 2, 3, 4. 4 flamingos. One more flamingo joins the hunt. How many flamingos are there in total? To find out, we can write a number sentence. 4 plus 1 equals 5. 2 more flamingos join the underwater fish buffet. How many are there altogether? 5, 6, 7. 5 plus 2 equals 7. What if 3 flamingos walked away from the group of 7? 7 minus 3 equals 4. 2 of the flamingos searched elsewhere for food. Now how many are left? 4 minus 2 equals 2. Then these two walk away. 2 minus 2 equals 0. All the flamingos have left. No more flamingos here. Okay, now try this. Here are 4 penguins. Let's add 0 penguins. 4 plus 0 is still 4. Adding 0 is adding nothing. The number stays the same. Now subtract 0 penguins. Same deal. The number stays the same. Adding things to a group makes it larger, and subtracting things makes the group smaller, unless you add or subtract 0 things. And if you subtract everything there, the group becomes the smallest it can be. Gone.
If you pay attention, you realize that you often ask questions about how many or how much. Like, how many penguins are there? These are mathematical questions people ask every day, and they often use addition and subtraction to answer them. In Mexico, these ranchers earn money by selling their cattle. They need to count the cattle to be sure how many they have and how many they sold. Every month, each rancher rounds up his cattle and takes them to the market to sell. By doing so, he adds to the number of cattle at the market. Each time he sells an animal, he subtracts it from the total number he owns, and the buyer adds it to his total. So math is important to a cattle rancher. Addition and subtraction help him keep track of how many cattle he has. Let's see other examples of addition and subtraction. It's fun to watch pizza being made. The dough, the cheese, the sauce, and of course, lots of healthy tomatoes. Larry is making a large pizza that will have many tomato slices. Let's count the number of tomato slices Larry is adding. He starts with 2. Then he adds 2 more. That makes a total of 4 tomato slices. We can write it as a number sentence. 2 plus 2 equals 4. 2, 2, and 4 are one-digit numbers. Larry adds many more tomato slices before he puts his pizza in the oven. Now there are more than 10. Adding slices gives us a greater number of them. We use math to figure out how many. Now Larry's customers get to eat and enjoy. You can find lots of beautiful things in the Atlantic Ocean. Large coral reefs, beautiful fish like purple tang and yellowfin. You can find sharks and seal and many different types of shells. These are conch shells. Charles collects them in a cage under the water in the Caribbean. Every day he takes some shells out to give to people on the beach. They use the shells as decorations or even as noisemakers. When Charles takes shells out of the cage, he subtracts them from the number he has. Let's look at these 7 shells. Charles carries 2 shells to the surface. That leaves 5 shells. We can write this subtraction as a number sentence. 7 minus 2 equals 5. The subtraction symbol means we take the number after it away from the number before it to find out how many remain. Green sea turtles live along coastlines where the water is warm, like here in Malaysia. Females lay their eggs only at night. The eggs take about 2 months to hatch. These park rangers protect them so the tiny turtles can get to the water safely. First, they carefully lift the eggs out of the sand. They have 12 eggs so far. We write the number 12 like this. It has a 2 in the ones place and a 1 in the tens place. Now look, 2 more eggs. How many does he have now? The ranger started with 12 eggs, the number already here. He found 2 more eggs, so we can add 2. To add 12 and 2, you add the numbers in the ones place first. In this case, 2 plus 2 equals 4. 2 has nothing in the tens place, but the 12 has a 1 in the tens place. So that 1 is added to nothing in the tens place of the other number. It is brought down unchanged. The result is 14. This can be written as a number sentence. 12 plus 2 equals 14. The 4 in the ones place comes from adding the 2's together. The rangers finish collecting the eggs and take them to a safe place. After the baby turtles hatch, they head for the water. Now the total number of turtles in the ocean has increased. Years from now, some of these turtles will return to this very same spot. Math lets us add together anything that can be counted, no matter how large the numbers are.
Counting tells you exactly how many. For example, it's simple to count these books. 1, 2, 3, 4. But what if there are lots of books? This is too many to count quickly and easily, but you can estimate or come up with a number close to the exact amount. Watch. This big group of books is made up of 5 smaller groups. 1, 2, 3, 4, 5. Each pile seems to have about 4 books. Some may have a little more, some a little less. But since each looks like it has about 4, let's estimate. 4 plus 4 is 8. Another 4 plus 4 is 8 again. Both 8's together, 8 plus 8 equals 16. Finally, we add 4 more. That's 20. You can estimate there are about 20 books here. Now let's find out the exact number.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 books.
19 books. The estimate of 20 books was just a little more than the true number of books, 19. Let's see how useful estimation can be. In the western state of Alaska live caribou, large wild animals in the same family as reindeer. Scientists need to count them to learn if the number of caribou is increasing, decreasing, or staying the same. But getting an exact count is impossible because there are so many. In fact, Alaska has twice as many caribou as people. So scientists must estimate. Here's one way they do it. At certain times of the year, caribou form large groups. The scientists take pictures of these groups from an airplane. Then they count the caribou in the pictures. Of course, not all the caribou are here, but scientists are able to come up with an amount close to the true total number. Let's try something similar. How many caribou are in this picture? It's hard to know exactly. Now look at the caribou in groups, as the scientists do. How many are in this area? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 caribou. We can see that this group looks a lot like the first one. So they each seem to have around 8 caribou. Since there are 2 groups, we estimate that there are 8 plus 8, or 16 caribou. In fact, there are exactly 14 caribou here. Our estimate of 16 was just a little more than the true total of 14. Estimation gives us a number close to the exact amount. It's faster and easier than counting things one by one. There are all sorts of very tall things in the world. You can estimate how tall some of these things are by comparing them to the heights you know. Let's try. The Clydesdale horse is known for its strength and its size. Its feet are huge, about as big as a dinner plate. But can you estimate the height of this Clydesdale? Try comparing it to something you know. For centuries, horses have been measured in hands, by counting the number of adult human hands it takes to reach the horse's shoulders. To estimate the height of this horse, let's first try to estimate how many hands to reach halfway up. About 8 hands. Now the remaining distance to its shoulder is about the same. So add another 8 hands to our estimate. 8 plus 8 is 16, our estimate for this horse's height. Clydesdales usually measure between 15 and 18 hands high, so by our estimate, this horse appears to be average height. An exact measurement could be made with a special measuring stick. Estimating height gives us a rough measurement when we don't need to know exactly how tall something is. You don't have to know the exact cost of everything you're buying to get a good idea of whether you have enough money. You can estimate. Karen and Margaret want to buy a t-shirt, a sweater, and a jacket. The prices are $59.99 for the jacket, $19.99 for the sweater, and $11.77 for the t-shirt. Karen and Margaret can estimate the total cost by using the numbers on both sides of the decimal point. $59.99 is close to 60, $19.99 to 20, and $11.77 to 12. We can round each number up to the nearest whole dollar amount. Then, by adding the new front-end digits, 6 plus 2 plus 1, in the tens place, we get an idea of how much the items will cost. 9 tens, or $90. Add the $2 in the ones place, and you've got a pretty close estimate of $92. Karen and Margaret know they'll be spending about $92. Just to check, let's see how close the estimate is by adding up the exact total cost. $59.99 plus $19.99 plus $11.77 is $91.75. As expected, the estimate of $92 is a little more than the true cost. Estimation is a quick way to get an amount when the exact number is not needed.
You may think math class is the only place to add and subtract. But really, people add and subtract all kinds of things in all sorts of places every day. When we add objects, we increase how many there are. When we subtract objects, we decrease how many there are. Here are 2 horses together. If 1 horse is added, there will be 3 horses in the group. We can write this with the number sentence 2 plus 1 equals 3. If 1 horse walks away, it is subtracted from the group, and the group's number decreases. 2 horses are less than 3. We are now back to the original number of 2 horses. The Galapagos are a chain of islands in the Pacific Ocean. It's one of the most protected places on Earth. Home to Galapagos fur seals, tortoise, and stingrays. 2 fur seals play near the ocean floor. 1 more seal joins them. A number sentence shows how to add this seal to the others. 2 plus 1 equals 3. 3 is a greater number than 2. When we add seals, the group becomes larger. The new total is 3 seals. Now suppose 1 seal swims away. 1 seal is subtracted from the group. We can write it as a new number sentence. 3 minus 1 equals 2. When we subtract, the group becomes smaller. 2 is less than 3. Now we're back to the original number of 2 seals. Notice what happened. If you add one number to another and then subtract the same number, you will end up where you started. In our example, we started and ended with the number 2. We added and then subtracted the number 1. See how subtraction can undo addition. Three elephants feed in the bushes along the Nile River in Africa. It's a mother and her 2 babies. When she leaves, she is subtracted from the group. We write it as a number sentence like this. 3 minus 1 equals 2. The group now has 2 elephants, and 2 is smaller than 3. What happens if the mother elephant comes back? We can add her to the group with a number sentence like this. 2 plus 1 equals 3. See how this time adding undoes subtraction? Adding the one that was subtracted gets back to the original number, 3. Even among elephants in Africa. You might think addition and subtraction are only used for objects we can see and count. But addition and subtraction can also be used for things we can feel, sense, and measure, like temperature. Although we can't see it, we can feel the temperature by how hot or how cold it is. And we can measure it with a thermometer. The indicator on a thermometer goes up and down as the temperature changes. The numbers next to the indicator tell us how hot or how cold it is. It's a beautiful sunny day at the beach. The thermometer shows that the temperature is 80 degrees Fahrenheit. Uh-oh, rain clouds. It looks like they're coming our way, and the temperature just dropped. The temperature was 80 degrees, now it's 70 degrees. It went down 10 degrees. We can show the temperature drop in this number sentence. 80 minus 10 equals 70. Rain clouds can change and move quickly. They have disappeared and the sun is out again. The temperature goes up 10 degrees. Just as we wrote the temperature decrease in a number sentence, we can show the temperature increase in one too. 70 plus 10 equals 80. Adding 10 to 70 gets us back to the original measurement of 80 degrees. It works both ways too, because addition undoes subtraction and subtraction undoes addition.